To size the service entrance for a small commercial laundromat with 10 washers, 12 gas dryers, and a single-phase 120/240-volt service, one must follow a series of calculations and considerations. The first step involves determining the load calculations for each piece of equipment. Firstly, consider the washers. Each washer uses approximately 2 kilowatts during the extraction cycle. Assuming all 10 washers run simultaneously, the total washer load is calculated as 2 kilowatts multiplied by 10 washers, which equals 20 kilowatts. Secondly, the dryers must be considered. Each gas dryer consumes approximately 3.5 kilowatts of electrical power for the motor and controls. Assuming all 12 dryers run simultaneously, the total dryer load is calculated as 3.5 kilowatts multiplied by 12 dryers, resulting in 42 kilowatts. Thirdly, other loads such as lighting, ventilation, and other miscellaneous electrical requirements must be estimated. For this example, let's estimate 10 kilowatts for these additional loads. The second step involves calculating the total load by summing up the individual loads. The total load equals the washer load plus the dryer load plus the other loads. Therefore, the total load is 20 kilowatts plus 42 kilowatts plus 10 kilowatts, which equals 72 kilowatts. The third step involves determining the minimum service amperage. For a single-phase 120/240 volts service, the minimum service amperage can be calculated using a formula. The minimum service amperage equals the total load divided by the product of 240 volts and a power factor of 0.8. Therefore, the minimum service amperage equals 72 kilowatts divided by the product of 240 volts and 0.8, which calculates to 150 amps. The fourth step involves sizing the service entrance. The service entrance should be sized to accommodate the minimum service amperage and provide for future expansion. Based on the calculations, a service entrance of 200 amps is typically adequate for a small commercial laundromat with these loads. There are additional considerations to take into account. If the laundromat operates during peak hours, consider increasing the service amperage to prevent overloading. Always consult with a licensed electrician or local building code requirements to verify the appropriate service entrance size. It is also wise to allow for additional capacity for future load growth or the possibility of adding more appliances. In summary, firstly, calculate the individual loads for washers, dryers, and other equipment. Secondly, sum up these loads to determine the total load. Thirdly, calculate the minimum service amperage using the appropriate formula. Fourthly, size the service entrance based on the minimum amperage and future expansion needs. Finally, consult with professionals and local codes to ensure compliance and safety. The load calculation for the washers involves determining the power consumption of each washer during its operation, particularly during the extraction cycle, which typically requires the most power. It is important to obtain the manufacturer's specifications for the power consumption of each washer model being used in the laundromat. These specifications are usually found on the appliance's nameplate or in the product documentation. Multiply the power consumption of a single washer by the total number of washers to determine the total washer load. This calculation assumes that all washers are operating simultaneously at their maximum power consumption. This is a conservative approach that ensures the service entrance is adequately sized to handle the maximum potential load from the washers. The load calculation for the dryers involves determining the power consumption of each dryer. Although gas dryers primarily use gas for heating, they still require electrical power for the motor, controls, and any electronic components. Again, refer to the manufacturer's specifications for the electrical power consumption of each dryer model. Multiply the electrical power consumption of a single dryer by the total number of dryers to determine the total dryer load. Similar to the washer calculation, assume that all dryers are operating simultaneously to provide a conservative estimate of the total dryer load. The load calculation for other loads involves estimating the power consumption of various miscellaneous electrical loads in the laundromat. These loads may include lighting fixtures, ventilation fans, water heaters, and any other electrical equipment used in the facility. Estimate the power consumption of each of these loads based on their specifications or by using typical values for similar equipment. Sum up the power consumption of all miscellaneous loads to determine the total load for other loads. This estimate should account for all potential electrical loads in a laundromat to ensure the service entrance is adequately sized. Calculating the total load involves summing up the individual load calculations for washers, dryers, and other loads. This provides a comprehensive estimate of the total electrical demand of the laundromat. The total load is used to determine the minimum service amperage required to supply the facility with adequate power. Ensure that all load calculations are performed using consistent units, such as kilowatts, to avoid errors in the total load calculation. The formula for calculating the minimum service amperage for single-phase 120/240 volt service is derived from Ohm's law and the power formula. The power formula states that power equals voltage multiplied by current multiplied by the power factor. In this case, the voltage is 240 volts, which is the standard voltage for single-phase service in the United States. The power factor represents the efficiency of the electrical system and is typically assumed to be 0.8 for commercial applications. Rearranging the power formula to solve for current gives current equals power divided by the product of voltage and the power factor. This formula is used to calculate the minimum service amperage required to supply the total load of the laundromat. The service entrance should be sized to accommodate the minimum service amperage calculated in the previous step. However, it is also important to consider future expansion and potential increases in electrical demand. As a general rule, it is recommended to oversize the service entrance by at least 25% to allow for future load growth. This ensures that the electrical system can accommodate additional equipment or appliances without requiring a costly upgrade to the service entrance. A service entrance of 200 amps is typically adequate for a small commercial laundromat with the loads described in this example. However, the actual size of the service entrance may vary depending on the specific electrical requirements of the facility. When operating during peak hours, the electrical demand of the laundromat may exceed the calculated minimum service amperage. This is particularly true if all washers and dryers are operating simultaneously at their maximum power consumption. To prevent overloading the electrical system, it may be necessary to increase the service amperage to accommodate the peak demand. A load study can be performed to determine the actual peak demand of the laundromat and ensure that the service entrance is adequately sized. Consulting with a licensed electrician is essential when sizing the service entrance for a commercial laundromat. A qualified electrician can assess the electrical requirements of the facility, perform load calculations, and recommend the appropriate size for the service entrance. Additionally, a licensed electrician can ensure that the electrical installation complies with all applicable codes and regulations. Local building code requirements may also dictate the minimum size for the service entrance. These codes are designed to ensure the safety and reliability of electrical systems and must be followed when sizing the service entrance for a commercial laundromat. It is important to research and comply with all local building code requirements to avoid potential violations and ensure the electrical system is properly installed. Allowing for additional capacity for future load growth is a prudent approach to sizing the service entrance for a commercial laundromat. As the business grows, there may be a need to add more washers, dryers, or other electrical equipment. By oversizing the service entrance initially, the electrical system can accommodate these additional loads without requiring a costly upgrade in the future. Consider the potential for future expansion when sizing the service entrance to ensure the long-term reliability and scalability of the electrical system. The possibility of adding more appliances should also be considered when sizing the service entrance. If there is a chance that the laundromat may add more washers, dryers, or other electrical appliances in the future, the service entrance should be sized to accommodate these additional loads. This will prevent the need for a costly upgrade to the service entrance when new appliances are added. Plan for potential future appliance additions when sizing the service entrance to ensure the electrical system can meet the evolving needs of the laundromat. The estimated 10 kilowatts for other loads is not the only source. It should include lighting, ventilation, water heating if electric, point-of-sale systems, and other general-purpose receptacle circuits. To determine what the actual demand is would need a breakdown of each load. Lighting. Use the lighting fixture schedule to add up all the wattage of the lighting, and that is the load of the lighting. Ventilation. If there are exhaust fans or supply fans, the nameplate will have the amperage of the unit times the volts times 1.732 if it is three-phase. Then divide by 1000 to get kilowatts. Do not forget the power factor too. If there are electric water heaters, that is simply kilowatts that the heater will draw. Point-of-sale systems will be very small, but that information should also be on the nameplate. Then, of course, the general-purpose receptacles around the laundromat. Those can be estimated at 180 volt amps per receptacle. All these items will contribute to the estimated 10 kilowatts. If you are running the laundromat during peak hours, the amount of current draw will be at its highest. This is because people are off work and doing laundry. The utility company may also be charging a higher rate at this time. Some laundromats are 24 hours, and so the peak hours would be dependent on the local area. Typically it's right after people get off work and before they go to bed. This may be the contributing factor to increasing the service amperage. The licensed electrician will also know what local codes are as well as the local utility company requirements too. They may have specific requirements that need to be adhered to. The electrician should be familiar with the National Electric Code as well. The National Electric Code is a document that is updated every 3 years, which has best practices in electrical installations. One of the key things to consider is that you need enough space in the panel for all the breakers. You may also want to have spare breakers installed in the panel for expansion as well. Also note that 200 amps is the most common service entrance size, even though the calculations call for 150 amps. This is because that is the standard size. Electricians are also very familiar with installing 200 amp service entrances. Also ensure that the wire size is appropriately sized for the amperage that is being used. This information can be found in the National Electrical Code in Table 310.15. This table will have information on the ampacity of conductors based on their size and insulation type. The electrician will take into account voltage drop as well. Voltage drop is when the voltage at the end of the wire run is less than the voltage at the beginning of the wire run. This can be caused by long wire runs or undersized wires. If the voltage drop is too high, it can cause equipment to malfunction or not work at all. The National Electrical Code has recommendations on the maximum voltage drop that is allowed. The electrician will perform voltage drop calculations to ensure that the voltage drop is within the acceptable limits. Finally, documentation of all the calculations performed should be provided. These calculations need to be given to the local building department and electrical inspector. This ensures that the electrical installation complies with all applicable codes and regulations. It also provides a record of the electrical system for future reference. All of these steps should be followed and will provide a safe and reliable electrical system for the laundromat. Remember to always consult with a licensed electrician to ensure that the electrical installation complies with all applicable codes and regulations. It is important to follow all safety precautions when working with electricity. Electricity can be dangerous, and it is important to take all necessary precautions to avoid injury or death. Wear appropriate personal protective equipment such as safety glasses, gloves, and insulated shoes. Do not work on electrical equipment when it is wet or damp. Always disconnect the power before working on electrical equipment. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. By following these steps and safety precautions, you can ensure that the electrical system for your laundromat is safe, reliable, and compliant with all applicable codes and regulations.